Yes, this is a continuation from previous lecture. So this is the end of yester classes slides. When a charged particle moves freely in a magnetic field, that is to say, experiencing only the magnetic force, the velocity is at right angles to the force at all times. No matter how the force changes the velocity, the force continues to change with it. The force is always at right angles to the velocity. And the QVB stays at right angles to the velocity. Now, when you've got a force, when you've got an acceleration at right angles to your velocity, that is the defining characteristic of having circular motion. Circular motion is an accelerated motion, and when you move in radius r at speed v, the formula that we were just revisiting is v squared divided by r. I have built you up to this point in the previous review questions just now. Your challenge now in question, oh my God, N, in question N, is to give me an algebraic, I'm sorry, excuse me, an algebraic expression for the radius of curvature of a charge moving in a magnetic field. You have v squared on r acceleration. You have F equals ma. You should remember QVB is the magnetic force. Find R. And you can work with your classmates on the algebra. Find R, and it is not acceptable to say it's right there. I found it. I'm done. Help each other with algebra, people. If your final answer has R in it, R equals some function of R is not okay. Okay, Kelly. Okay, hold on a second, Kelly. I'm not asking you to take this one expression and solve for R. Also, this is not a multiplication. This is a subscript. Centripetal acceleration is speed squared divided by radius of curvature. What are the other two equations we just reviewed? Force equals ma, and force on a charged particle in the magnetic field is QVB. I'm asking you to combine three equations. A equals v squared divided by r. Force equals mass times acceleration. And force equals QVB together. Solve for r in simplified simplificationist terms. Don't forget to simplify. Oh, you see it? I thought I heard no. Who is completely and totally lost? I'm asking you to find the radius of curvature for a charged particle moving in a magnetic field. I'm asking you to use the principle of algebraic substitution to combine three equations. Huh? N. N for not my problem. I don't know. N for Newton. There we go. N for centripetal acceleration. Absolutely magic, isn't that right? Is that the song? No, not absolutely magic. Some other word magic. Huh? Yeah, Newton's actually a member of Insane Clown Posse. No, Newton was 100. Newton died 100 and some years before magnetism was deeply understood. Some of the fundamental characteristics of magnetism that we'll discuss towards the end of the semester, later in the semester, hadn't been discovered when it was in the grade. Okay, so here's what I was looking for. I guided you in the previous part to get the formula radius equals mv squared divided by force, right? Deja vu, is that correct? Is that right? And then we've got this force equals qvb. If we use the principle of algebraic substitution, instead of writing F, we could just write qvb. That's the way algebra works, right? Now, also according to the way algebra works, if I've got v squared divided by v, v goes away and you're just left with q squared over qb, right? Right, this becomes squared over qb, is that right? V disappears? No, how am I lying to you? What does it mean to have v squared? It means I've got v times v. V times v divided by v is just one v is left. mv over qb. That is the expression that we've been. Oh God, what's the from the wasteland? A rough equation stumbles towards Bethlehem waiting to be born. This is called gyro radius or cyclotron radius. You will be tested on it. The meaning of it is if I flick a proton into a magnetic field, a constant magnetic field, a simple magnetic field at right angles to the velocity, the proton doesn't just go straight through. The proton doesn't arc in a parabola. The proton doesn't go in a sine wave. The proton will spiral in general, so in circular orbits in plane perpendicular to the field. And the shape of the orbit, the shape of the circle is very characteristic of stuff. What does it depend on? Characteristic of what? R is equal to what over what? The radius of the orbit depends on mass, speed, charge, and magnetic field. This is bred, or was, back in the olden days, back before I was a gray-haired professor, I used to be a scientist in training, used to do research myself. And back in those halcyon days of my youth, before half of you were born, not really, but back when you were in elementary school, when I was doing my PhD, this was my bread and butter for identifying charged particles coming out of a subatomic explosion. What we would do is we had a known magnetic field. Most of the fragments, when you blow apart things, when you blow apart a proton into subatomic fragments, subnucleonic fragments even, have charge equal to 1 electron charge. You can measure their velocities, and if you know velocity, charge, and magnetic field, I mean, you control the magnetic field, then you can recognize their mass based on their curvature. So I would blow something up, and based on how tightly curled the tracks were, I would be able to say, oh, hey, there's a proton. Oh, that's an electron. Look, Eta meson. Hi, Eta. So on and so forth. Actually, Etas are disappeared because they have no charge. That's a pi meson. There we go. Hi, pi. So on and so forth. This is absolutely central to at least that area of physics, because this is how you recognize different particles. Subatomic particle fragments are very unfriendly. They do not step onto the scale. They are very shy about their weight. You have to infer their weight using something clever. You have to be able to get their weight based on how tight a turn do they make in a magnetic field. Suppose I've got a proton screaming along at, Mike Myers impression, 1 million miles per hour. Meters per second. Sorry, I forgot which class I'm in. 1 million meters per second. A proton at 1 million meters per second into the Earth's atmosphere. I don't remember what the magnetic field is at altitude. Let's say it's the 52 microtesla here on Earth's surface. Find the radius of curvature of a proton at 1 million meters per second. Oh, right. I need to tell you. Proton mass, 1.67, 10 to the minus, oh God, 24. Pretty sure that's right. Someone check me if I'm wrong though, please. That is the charge on one proton. This is the kilograms of one proton. I'll put that on there too. QP, charge on a proton, is 1.60, 10 to the negative 19. Coulombs. Coulombs. Nope. If there are constants, I will always either have written them already on the test or shamefacedly write them on the board. I don't care that you memorize constants. You need to know the SI prefixes. You need to know what a micro is. You need to know what a nano is. If I give you the coulombs in one electron, you should be able to find the number of electrons in one coulomb. That's a conversion that I expect you to be able to do. They're just reciprocals. But memorizing all the core numbers, no, you don't need that. This is question O, by the way. Question O. Not the frequency for dog's sake. Radius. The gyro radius. $27. Thank you, Alex. I was wrong. Alex looked it up. It's 27. Only off by a factor of 1,000. Six micro millionth. Like the mega millions, the micro millionths. I tell you, if every micro Tesla field, how many Teslas is that? Oh, what did I tell you? I told you what about the magnetic field? So what would you plug in? Just plug in 50, you'll get the answer on. It is a biggie. I think I'm actually overestimating the speed. I think the speed is actually coming in a bit. So I'm not an astrophysicist. I don't have this number stuck in my head. Solar wind speeds. But it's actually of interest to ham radio operators. Solar wind information tells us a lot about how the upper atmosphere is going to reflect our signals, but it hasn't stuck in my head. And you're correct, by the way. Although you should put units. Meter, I hardly knew her. All right, I'm getting a number of people who are really struggling with 10 to this. Really struggling with 10 to this. Really struggling with 10 to this. Let me give you a million, billion, gazillion dollar tip for how to do multiplication with scientific notation. Don't do the 10 to this in your calculator. Like a good third of you are screwing up the 10 to this, which is screwing everything else up. You will not pass. You shall not pass if you screw up the exponents. So what's the formula? MV over QB. How I would write this if I were y'all in my calculator is 1.67 times 1 divided by 1.6 times 5.0 times all the powers times 10 to the what? 10 to the, what's m's power? 27. Sorry. Thank you, Alex. V, what's the power for V? 10 to the 6th. Then what's the power for Q? 10 to the negative 19. What's the power of the B? Well, it's 50 times 10 to the minus 6. That'd be 5 times 10 to the minus 5. Look, you just pull out the 10 to this. And then there's a trick for if you add and multiply, sorry, if you divide and multiply powers. What happens if you've got 10 to the 10 times 10 to the 20? You add them. What happens if you have 10 to the 10 divided by 10 to the 20? Yeah, exactly. So the second part is really simple. You just turn this into 1.67 over 1.6 times 5.0 times 1, whatever, times 10 to the minus 27 plus 6 plus 19 plus 5. You can do that in your head. What's 6 minus 27? What's 27 minus 6? And then throw a minus sign on it, you got negative 21. What's 19 minus 21? 19 is smaller than 21. Negative 2 plus 5. I didn't overestimate your math abilities. Let's into the third. 1.67 divided by 1.6 times 5 times 10 to the third meters. Final answer works out to be 210 meters. Ish. 208 point. I don't care.
So the thing is when I put it in on my calculator, I got 2.08. So
2.08 times 10 to the what?
so I guess it would be accurate then to say this is.
I'll come over and take a look at your calculator in 2 shakes of a lamb's tail. But let me give the next challenge for everyone. Okay. First off, do as K Money is doing, make sure that you can get to be able to multiply these numbers in your calculator and get the right answer. I would encourage you also to be able to multiply powers by hand, as the fewer things that you type into your calculator, the fewer places there are to screw things up. So that's why I suggest pulling out the 10 to this. Do what it takes to get what you need. My challenge now, though, is to say, all right, we know how far across the circle is. Can you find the time it takes to take that path? I've given you some information. Can you find the time it takes to go around this circle? That's the next challenge. Now I'll go over and look at your. once round to go all the way around a circle. It's spiral if you look at the third dimension, but in the plane of well, in the plane perpendicular to the magnetic field line, going in a circle. Speed is very important. You don't need to think about spiral. Pretend it's just going in a plane. Hey, what's speed? Distance per time, right? When I'm going in a circle, what distance have I gone every orbit? Right? I've got one circumference worth. Everyone nod along with me, right? If I go around, I've gone pi r squared distance, right? Everyone agree? Distance around a circle is the famous formula. Distance equals pi r squared, right? You're not nodding along. I'm lying to you. 2 pi r. Don't make me bust out a psychology textbook about agreeing with authority just because he's authority here, right? Also, you see how many mistakes I made? 2 pi r. Okay, so distance is what? 2 pi r. The time is, so that's what I'm looking for. And what's that equal to? Speed. 2 pi r is the circumference. Distance divided by time is speed. I've got speed. I can find circumference trivially, find time. Wow, that's a long time. Please mind the 10 to those. I think some of you might not be using times 10 to the correctly in your calculator. I would encourage you to do this separately if you struggle with this. Okay. One more second. I'm really hoping though. Please, 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 please take a second, step back and think. I got a whole bunch of wrong answers, and this is distance equals rate times time. This is not an advanced kinematic equation. If you go in a circle of radius, what did we find out? 210 meters, you've got a distance of 1,310 meters. If you're going at a speed of 1,000,000 meters per second, you need to be able to find out how long it takes. You should not have to dig back into your notes from last semester to find time out of this distance, speed, and time. Please check your work if you've done it. Turn to your neighbor and express to them, how do you find time given distance and speed? Okay, so here's how I do this problem. If I know that my speed, the definition of speed is distance divided by time, and I already have that speed is 10 to the 6th meters per second and distance is 1300 meters. I want time. 1 million equals 1300 divided by what? I could algebraically rearrange this. I'm sorry, algebraically rearrange this as follows. Multiply both sides by t, I get 10 to the 6th t equals 1300. I divide both sides by 10 to the 6th to get t alone. 1300 divided by 1 million is 1.3 milliseconds. Yeah? Do I expect you to remember v squared divided by r? No. Do I expect you to be able to say that distance divided by time is speed? Yes. I reserve the right to give this to you on the test on Wednesday at this level. I want you to remember, I want you to write down the gyro radius equation. Sure, great. Learn it, live it, love it. You should be able to find the time it takes to go once round based on logic. Here, follow-up question, follow-up question. How many times per second? Follow-up question. How many times per second does this happen? If one orbit takes 1.3 milliseconds, can you reason out with your classmates how to find out how many orbits happen in each second? This is question Q. Find the orbits that happen in 1 second. Uh, we go 1300 meters, but meters is not the same things as orbits. I'm asking for the number of orbits, number of complete circles you make. Again, if it takes 1.3 milliseconds for one orbit, how many orbits do you get in 1 second? Follow-up question. 3 friends work very hard together and in this economy earn 25 shiny cents. Can you work out how much money did each person earn? Don't say it out loud. Put it in the Google form. Question R. How many dollars per person do we have? Follow-up question, question S. how many people per dollar? So how many dollars per person? Now put it in the Google form. Put it in the Google form. Question R is how many dollars per person? Question S is how many people per dollar? Nope. No, are you kidding? That's like back in the 2023 economy. Three friends work together and they are paid a fortune. What are you, a millennial? So again, the question is, three people work together, slave away for our corporate overlords, and are paid a quarter for all three of them. All three of them share the quarter. They take turns holding it under the pillow at night. I don't know. How much money per person is there? Follow-up question, how many people would it take to earn $1? Question T, what is the relationship between these two numbers? Question T, yes, can you describe the relationship between 8.3 cents per person and 12 people per dollar? What is the mathematical relationship between those two numbers? The correct answer for part R is about 8.3 cents. 8.25 cents. Correct answer for S is 12 people. What's the relationship between those two numbers? How do you get from knowing dollars per person to know how many people per dollar? The relationship between those two quantities. Can you give me a formula to calculate dollars per person if you know people per dollar? What's the relationship between orbits in 1 second and seconds per one orbit? Mathematically, how could I predict the seconds per orbit if I knew the orbits per second and vice versa? It's the same thing as what I just did with the dollars and the money example. If you know the dollars per person, you could find the people per dollar by flipping it. This is the idea of a ratio. You can express it in either way. So the correct answer for part Q is about 770 orbits. 770 cycles happen in 1 second. Just like one cycle takes 770th of a second. The relationship between these two is called the relationship between a period and a frequency. Frequency is inverse period. Period is inverse frequency. Okay. What we did on the previous slide, what I'm getting after is you found an expression for the time for one orbit. That's called a period. Frequency is 1 divided by period. Also called 770 hertz. Insert menstruation fund. I think I did that last semester. No, I didn't. How do we know that physicists as a whole are pretty blatantly there's rampant sexism in my damn field? Because clearly, period hertz, frequency, I don't know. I don't have a uterus. Ask somebody else. Ask your classmates. Exactly. Okay, anyway. Okay, for exam next Wednesday, for exam 1 week from today. On Monday, we're going to have a chance to be going over things. The vast majority of what we're gonna go over is circuit stuff, because that's what's occupied what? 3 out of the last 4 weeks, right? What do you need to be able to do with magnetism? You need to be able to identify what is a magnetic field, identify its direction, find the direction of force on a charged particle, and apply these formulas that we've just done. QBB, QB over MV, and be able to turn a circumference into finding a time or frequency. You can do this stuff, you'll ace it. Please, run, do not walk to your nearest textbook, YouTube video, favorite professor's office hours or whatever, and learn the definition of parallel and series and how to identify them. Do not forget, do not forget, do not forget. Also, don't forget that I love you. Adios. Your homework. There will be homework now that I know how far we've gotten, what we need. I will be assigning.